This Week in Radio Tech, episode 291, is brought to you by Axia Livewire Plus. Livewire Plus includes fully compliant AES-67 audio over IP built in, Livewire convenience plus worldwide connectivity. By the incredible Omnia 11 FM HD with chameleon processing technology and ultra multiband limiter system. And by Lotto and the Crystal Clear virtual radio console. Crystal Clear is the console with a multi-touch touchscreen interface. We compare two different brands of audio over IP mixing and routing systems and find they're pretty similar in terms of network planning and wiring. Stephen Poole of Crawford Broadcasting joins Chris Tobin and Kirk Harnack looking at Wheatnet and Livewire Plus. Plus, we're discussing options for secure remote access. Hey, welcome into This Week in Radio Tech. I'm Kirk Harnack, your host, and delighted to be here. It's episode 291, and this is the show where we talk about radio engineering, audio engineering, sometimes RF engineering, antennas, transmitters, microwave links, all kinds of stuff like that. And today's show, I'm really excited about because our guest today, we'll get to our guest in a minute, but I got to, our guest has been on the show before, but I didn't get to be here for that show. So I never got to talk to our guest on this show before. So he's agreed to come back, and he's got some wisdom for us about setting up audio over IP networks. And well, of course, our usual co-host, Chris Tobin, is here as well. Chris, glad you're here. Welcome in, the best-dressed engineer in radio. How you doing, buddy?
I'm doing well, thank you. All is good. Looking forward to this show. It's going to be fun.
How about a weather or radio report from New Jersey?
Well, the radio report, things are doing very well here in the New York City market. When it comes to the weather, though, it's a nice, balmy 25 degrees Fahrenheit. The real field temperature, 14 degrees. And after sunset, I'm told, there's a wind chill of about 0 degrees Fahrenheit expected. So it's going to be good. Got an Arctic blast coming from the north for the next 3 days.
That north, that's where those things come from, isn't it?
Yes, I think sometimes they call it the Alberta Clipper.
Oh, well, that's when they come up the East Coast, isn't it? Isn't that an Alberta Clipper?
Yes.
Yeah.
This one's coming from the other side. In any case, they're calling for record-breaking temperatures, I believe, on Saturday and Sunday. So it should be good.
Well, here in Nashville, it's about 40 degrees. And let's see, this morning, the low this morning was about 25. And the snow is mostly gone, but we're expecting a little bit more tomorrow morning, more on Monday. And then I know it's out in voodoo land, but we're looking at more snow, perhaps a snow bomb, just before my birthday around February 25th or 26th. So, but again, a butterfly could flap its wings in Brazil, and it'll all be different. So we'll have to get closer to the date and see what happens. So, Chris, this show that we're going to be talking about here, audio over IP, you're very familiar with the concept because you've built AoIP studios, and so have I. But I'm delighted to have our guest with us. Let's go ahead and bring him on. Stephen Poole. Stephen Poole is the market chief engineer for Crawford Broadcasting in Birmingham. Steve, welcome in. Glad you're here.
Hello there.
Delighted you could make it with us. And Stephen, a lot of folks know you because of your writing in is it Radio Magazine? Which magazine are you writing in?
I have done articles for Radio World, and of course, our company has a newsletter that all of us write for.
I read that thing every week because ordinary people can subscribe to the Crawford Engineering newsletter. Isn't that great?
Yeah, well, that's just how we roll. And by the way, it's going to be 60 degrees here tomorrow.
Oh, my goodness.
Yes, good for you.
Oh, man. I haven't been to Birmingham in a while. I was in Huntsville about a month ago, but I haven't been to Birmingham in a while. I ought to get down there. When's the next Daytona race?
I don't know. I don't remember. But
Okay.
You being a weather guy, you can appreciate this. You know, I forgot the miles. You know, a typical Southerner, I think in terms of the driving time, it's 2 hours from here to Huntsville. Two completely different locations when it comes to weather. They got an inch or two of snow. We didn't get anything.
Well, I'm a big fan of your buddy James Spann, who also has been on the show here, and he's world famous weatherman in Birmingham, and so I catch his reports pretty often. And yes, you're right. Northern Alabama might as well be Southern Tennessee in terms of weather, but when you get down to Birmingham, it's usually completely different.
Yep.
Amazing how that works. Hey, before we get into our show, I want to tell you about our first sponsor, and that's Axia and Livewire Plus. So we're going to be talking about audio over IP on the show today, so I might as well go ahead and mention Axia and their audio over IP. You know, Axia, actually, you could say Axia invented audio over IP for broadcast. Why? Because the audio over IP that existed before Livewire came along was all much too high latency to be useful on the air. When you talk to the microphone, it could be 10, 15, 20, 25 milliseconds or more before you'd hear your voice in your earphones. And that drives talent crazy. Produces a big comb filter effect in your ear. You really need about 3 milliseconds, 4 milliseconds, or less, of course, for it to sound like real live audio. And that's what Livewire did. They did that 15 years ago, producing the first audio over IP that worked with off-the-shelf switches, Ethernet switches, and the first to have such low latency and routable audio streams. Before that, the audio streams that other companies were doing, and it wasn't for broadcast. They were making audio over IP systems for other purposes, but they weren't, the original systems weren't routable. Kind of one direction only, this way or that, is kind of a bundle. And so the folks at Livewire, in fact, my friend Greg Shea is on the patent for doing some of the things that Livewire does. Well, now there's a new version called Livewire Plus. What does that mean? Well, it's perfectly backward compatible with everything that Axia has been doing for the last 11, 12, 15 years or so. But what it adds, the Plus, adds the AES 67 standard into the Livewire suite of standards. So now if you get something like an Axia X node, which is actually has very updated software, updated hardware, you go into that X node and you're gonna, let's say you're gonna have some incoming audio, you're gonna produce a stream from that. Well, you can choose a number of different stream types. There are several different stream speeds that are Livewire streams. Then there is an RTP stream, which makes it easy for that to cross borders and to go out over a private WAN, across fiber networks, any place where, let's say, the other end isn't on the same clock. That's an RTP stream. And that's what was used by Radio Sweden, for example, to send audio from the Olympics from Sochi, Russia, back to Sweden. That was an X node and RTP streams. The next kind of stream is the AES 67 standard stream. And a bunch of different companies got together and hammered out these stream types a few years ago. The AES 67 standard now is about 2 years old, I believe. The big news just lately that's coming out, if you pay attention to some of the social media feeds, or it's going to be in, I'm sure it'll be in the trade magazines, is the new AES 70 standard. That's a standard for control over IP. So for a couple of years, we've had AES 67. Different manufacturers build equipment, and they can talk to each other with audio. With AES 70, they can talk to each other with control, GPIO, and other routing messages and advertising messages. It's all included in AES 70. So my encouragement to you is just watch for that to happen. And the real message from all this is that you can go with AoIP now with real confidence. There are standards that companies all around the world are agreeing to, building to, and now there's more functionality being built into that with the AES 70 standard. So I want to say thanks to the TELUS Alliance and Axia for sponsoring this part of This Week in Radio Tech, but also for keeping everything backward compatible with Livewire and also adding AES 67 to the mix so that Livewire Axia gear can talk to other manufacturers as well. All right, let's jump into our show. Hey, if you don't know, Chris Tobin, a few years ago, built a multi-studio facility in New York City, a very high-profile place using Livewire. And Chris, why don't you take just a minute with us here and remind us of what your challenge was there and what you did at that facility.
Well, the challenge was take out the old analog infrastructure, which were Ward-Beck consoles, and replace them with IP-based audio system. And the other part of that equation was, by the way, you don't have new studios to do it in. You're going to have to do it in the existing studios. So while you're running the marathon, we're going to be changing your gym shorts, shirts, and the various shoes you're wearing, and you can't interrupt the run. Essentially, that's what we were told to do. So I had projected about 5 months to convert. Let me see. We had 4 studios, 4 studios and a little small master control, along with the associated edit booths, which were another 4, and do that all in about 4 or 5 months. We actually did the project very well. We did do it while we were on the air. We did not have any failures. Implementation went according to plan, and we came in a month early, so it was actually fun. So basically, the Livewire installation was pretty cool because since it's all Cat 5, or 5E at the time, we could pre-wire everything with a single or maybe a couple of pairs of wires in a studio, in a control room, and then in the master control, and then just start plugging in switches, plugging in nodes, and then the consoles themselves. And we were using the Element consoles. I guess you'd call them, would it be like first generation? The early versions.
Is that a second? Because you remember Tom Ray had the first generation, the Smart Surfaces.
We had the Smart Surface, and Element came out after that. Right, exactly.
Yeah.
So it was a fun project, and the reason we went with the IP audio approach was twofold. One, ease of use. Total cost of ownership was actually low, and allowed us to sort of future-proof our operation. And second, the newsroom operation was asking of engineering to try and do things that the old system just couldn't support. And we was like, well, we'd love to give you that, but we don't have enough mix minuses because the Ward Beck only has X. And, I'd love to be able to do that, but we don't have any room in the racks to add more equipment to give you that. So the thought was, well, time to look at something new. So Livewire came to play, and it was very nice. And what was fun about it was the installation went in a way that opened our eyes to the simplicity of distributed audio systems. And that's basically what I used to call it. Was we could now put a small little node in an edit booth or in an area where we had several cubicles where people were editing audio and producing writing, and just one node, and out from there we went to different things. Whereas in the past it would be, we all remember the 25 pair cable runs of Belden or Gepco, and half a dozen punch blocks and whatever else you had to do to get something going. The IP approach was great. One Cat 5 to a node, and then the output of the node was either XLR or RJ45, depending which ones we had, and that was it. And once it was in place, all it took was a couple of software changes or, on a web browser of a device, and you could move the audio around to wherever it had to go. So it was nice.
So I want to hear more about that, especially what you did to start planning, because one of the questions we get at Telos Omnia Axia is we get questions about people just, where do I start with IP addresses? How do I make this make sense? I don't want to build this out and then realize, now I did that wrong. I got to change all this stuff. How do you help people through that situation? And then, Stephen, if you'll listen to Chris's answer, I want to hear how it was for Stephen and how he started planning this thing when he started building his AoIP IP system. Chris?
Well, with the IP addressing, we did approach it in a way that sort of created an island for ourselves. So I chose an IP scope that was considered non-routable, 172.16.150. And the reason we did that was because we were in a combined operation at a facility that had other networks in it. I wanted to make sure there was no chance, in the event, and it can happen, someone from either IT or just some other person, a staffer, takes their laptop and plugs into a switchboard and found their way somewhere into the network and plugged in and thought they could get something. So there's no way we could have anything route around. That was the first very high level. We'll make sure that happens. Everything was static IP. Didn't do DHCP, didn't do DHCP reservations. We literally wrote out a spreadsheet and said, okay, each studio will have its own scope of IPs within this network, and this is how we're going to do it. So we knew that each room had a certain grouping. We kept to that, so the changes that were made was pretty much kept local to the rooms or workflow areas that required it, rather than just simply say, okay, here's a scope of 255 IPs and just pick and choose and do what you want. That was part of the process. That helped a lot, because when we did the documentation and broke it out that way, those on staff who are IT people that may not be broadcasters at least could recognize what we were doing and say, okay, I understand this, and just read the description of what that IP was doing. And that would just follow all the way through. And it worked out very nicely. And then it was just each cable run had its own cable ID, so when you looked at a cable number, you know exactly where it was going to and from, without having to go crazy looking for a book or a binder and say, oh, now where am I? So it was that was the first step. But the IP addressing, we actually chose one that was non-routable, so in case somebody plugged a router in, it wouldn't go anywhere. We had to do that because we had a few areas that were open to, I'll call the common space of the staff, and there's always somebody who is a do-it-yourself.
Plug in something in.
Oh, here's a port I can plug into. I take my little portable Wi-Fi router and go here. No. So it actually worked. We had a couple of times people try something. Go, I don't know why it's not working. I was like, yeah, you're not going to get anywhere with that particular connection. Thank goodness it worked. Then I take
one of the things I've noticed in some of the latest Axia gear is instead of having to assign an IP address, you can just assign a 2-digit or a 3-digit number to the device, and it will figure out its own IP address to use from that, which is it can save a little bit of trouble. Stephen, how did you go about planning, either cable runs, IP addresses, just the scope of work you're going to be doing when you started putting in or planning your Wheatnet installation there?
Well, I'll tell you what, there was a lot of deja vu listening to Chris, because we did pretty much the same thing, private network. We also made it so that, I'm sure he did the same thing, they were physically isolated. Everything on our AoIP network was physically isolated from anything having to do with any other network in the building, and that was on purpose. In other words, we literally ran separate wires, separate switches. It's a different network. We did the spreadsheet, static IP addresses. We do have to have, and anytime, one thing, this isn't particularly audio over IP. This is just your network security in general. Anything like that, we strictly and severely limit access to the outside world. For example, none of our workstation machines, we use RCS NextGen as our automation system.
Yeah.
None of those machines, except for 2 carefully prepared and protected machines, can access the internet. And getting in with VNC, it must be encrypted. And we were real big on the security. As far as what he's talking about, though, like with the spreadsheet and kind of like choosing a private network, things like that, we did pretty much the same thing here, because when you've got AoIP in general is going to have a lot of packets flying around.
Oh,
especially,
yeah. Constantly.
I think Chris said he had 4 stations. We have 5 here, so you've got a lot of packets flying around. And you don't want it. You don't want anything colliding. You don't want any congestion.
Yeah. And I take it it's probably similar for Wheatnet as it is for Axia. We've always said with Livewire, with a Livewire network, you need to select particular managed switches for a Livewire network, and if you have to, that network can carry other traffic in addition to the audio and control, but not necessarily vice versa. In other words, don't ask your business network to carry real-time, unbuffered audio over IP traffic. Would that be similar for you? Not that you built it that way, but yeah.
I mean, I'm not going to bore you with the details, but yeah, there are a few, like we have some satellite control stuff, and we have some of our transmitter site remote controls run on essentially the same subnet as our audio IP. But no, we pretty much do look at it the same way. The business network here is completely separate, totally separate.
So, Stephen, one thing that you've written about in some magazines is the issue of security, and sometimes I talk to people and I'm not sure they know what they're talking about, and they warn me, oh, that's not safe, that's dangerous, but I'm not sure that they know what they're talking about. So here's what I'm getting at. At my own radio stations, where we do have separate networks for Livewire and for business purposes, but we'll typically have one and only one computer that is outfitted with 2 network interfaces, and I don't know all about what's available in Windows or Linux for keeping traffic absolutely from crossing between those, but I'll VNC or TeamView into this PC on the business network NIC, and then I'll open a browser and I'll browse to IP addresses that are on the Livewire network. Is that safe, or what could I maybe do wrong that would make that not safe?
Well, the only correct answer would be it depends.
Okay. Yes.
I'm sorry. It would. It's actually sorry. You can tell I'm real good with this camera thing here. Let me think for a minute. I know that in general, Linux, of course, is a lot more robust in the separation that it will grant you between two separate network cards in the same computer. I can't speak for Windows, but I do believe, just simply because of the way packets are routed on a network, you know, as far as your net mask, ARP, determine it's a local address, get the MAC and all that, I think you would be reasonably safe. The general principle is that you want to completely close everything down and then only pinhole what people should get through. Now, I will tell you this, just to give you another idea. I do not go in through our business network. We go directly into our RCS NextGen network, but we do so through, it's an open source firewall called ClearOS. Okay. Is what we use. It's extremely good. It offers, and that's how I block people from getting on the internet with the system. But we all go in that way. And let me give you an example. One complaint you may hear is somebody will say, well, I recorded this over here on my laptop and I want to just be able to hook it up to your network so I can dump it into the automation.
Right.
And I'm sorry, I look at them and say, poor baby, you need to use a thumb drive. A little USB stick. No, you're not connected. Sometimes you just have to make rules like that. As far as your specific scenario, the reason I'm hedging my bets is because I'd really want to see it. I would go into your system and try to hack it, and then I could tell you if it was secure. Yeah. That's how I determine things. I actually run what's called an Nmap scan, and then I start looking at ports. I start probing ports. I would have to see how easy it would be to hack through that Windows setup.
You know, one thing that I would like to implement at my stations is that in order to actually close any ports that I have forwarded from the public internet to my business network. Now, I typically choose really weird port numbers, and that's just security by obscurity. It's not real security. It's just that it's not likely that hackers are going to go there.
It helps. It helps more than you think.
Yeah, I'm not going to I'm not going to map or forward port 5900 for VNC. First of all, I've got 10 machines I want to VNC into, so I've got some quite different port numbers that do also, and my router does port translation as well as port forwarding. So I use that, but that's just obscurity. What I really want to do, Stephen, and I just need to learn how to do this. And another guest that we've had on, Dave Anderson, is good at this. We've got MikroTik routers, and I'd like to just implement VPN connectivity from the few people who need it. Me, a couple of the station employees, and our friends in our support group. We have Rivendell PCs, and so Fred Gleason and his team could have VPN entry. Is that a good way to go and just close off any open ports to the outside world?
VPN would work. There another way you can do it, and the way I do it when I need to come in and work from home as often as not. We rely very heavily on Linux. Our audio network machines are Windows based, but anything that faces the outside world is going to go through a Linux box. Mm-hmm. And so I have a tendency, very frequently, I'll use a secure shell tunnel.
Ah, yes.
You set up a secure shell connection, you can connect a port, or bind a port to it, and then you can actually connect on that bound port number, and your entire, it's almost like you've set up a little point-to-point VPN.
Yes.
Just at a command line. It's a beautiful thing.
Yeah, our support people actually do secure shell quite a bit. I remember enough about it when they tell me what to type in. I'm in, and after that, it's like, oh man, I have no idea what I typed. Let me ask Chris Tobin. Chris, for remote access into your systems, what are some of your favorite tricks? What do you like to do and try to make sure you're safe?
The only remote access methods I've ever used and choose to use has been VPN. When we did our Livewire installation, I put together a computer with a firewall software. I think it was OpenVPN, and the firewall was a Linux-based firewall. I can't think of the name of it, but we used that, and that would get us in dual home PCs. I am fearful of, because Windows OS is designed to bind everything together, and it's just. I have a friend of mine who's a security computer person, and he just tells me horror stories of his clients when he gets there and finds out that one of the machines in the closet had 2 NIC cards, and he's like, "Well, this explains something." So, but yeah, we were doing VPN with. One of them was a Cisco router with VPN, and the other one was a pure firewall VPN solution, and that was our way in and out of the system. And we also put one between the business network and what I call the broadcast revenue network, which was our Livewire and automation system. So we had actually a firewall in-house between the 2 systems, just to make sure we were locked down, because this was back when those viruses were running rampant, and CNN and a few others got nailed. We made sure we were an island within an island at times on some of the systems, and the IT department at the corporate level was so annoyed with us because they were like, "We can't access your system to troubleshoot." And I said, "Well, that's okay. That's why we have a trouble list, and you contact those on the list, and we'll work with your people, and we'll get you in." "Yeah, but we should have access." No, it doesn't work that way, because we're generating revenue. This radio station makes millions and millions of dollars a year, and one wrong keystroke, and it goes to 0. Your office, in the business side, traffic log doesn't make it somewhere. Okay, we'll make do. Or maybe somebody's Outlook failed, or the email exchange server suddenly stopped. That's okay. But when the commercials don't play, and the news can't be heard, trust me, you will not like what happens after that. So, yeah, it was fun. It was a fun environment, because I was able to justify a lot of stuff because it was all revenue related. I used to just simply say, "These networks generate revenue. If you want to interfere with them, be my guest. I'll just like that in writing first, and I'll let you in."
Stephen, I don't know about you, but I like that name. This is our broadcast revenue network.
It is. BRN.
I like that. Oh, by the way, just for the sake of those who might not know, I realize most of the people who view this are very intelligent. They would have to be. But just for the sake of those who don't know, VPN, virtual private network, and VNC, of course, is virtual network computing. Remote, kind of like remote display.
Yes. And you know what? While we're on the subject of VPN, Steve, since you've written about this, know a lot about it, I get the sense that a lot of people think that a VPN is not only provides privacy, but somehow it also provides guarantee of bandwidth and delivery. And I want to, maybe you can tell us why that a VPN doesn't mean it's going to work. It won't work any better than the path over which the VPN is moving.
Yeah, it's still basically, without getting into all kinds of gobbledygook way out in the weeds, with a VPN you're essentially establishing in a known encryption path, an encrypted and protected, secured path, but it's still going over. If it's public, you're going over the public internet. I mean, just to put this in simple terms, you can set up a VPN with a dial-up modem, but you're not going to get better than 56K of transfer.
Yeah. Okay.
I set up VPNs with dial-up modems years and years ago.
Well, the 2 reasons to use VPN technology between 2 places would be, number one, to prevent other people from snooping on it, because it is encrypted. It looks like a bunch of random data to anyone who's sniffing it. But the other reason is that it lets you connect to an endpoint that otherwise you couldn't connect to, because you have to have the right keys to get accepted. And so it's a secure way of two people talking, and nobody else who might be listening could possibly listen, nor could they get into it even after you unplug, so to speak. So
unless they crack you with a man-in-the-middle attack.
Yeah, we know that's possible. But it doesn't. I have people say, well, to do a remote broadcast over IP, we'll just use a VPN. It'll work well. Well, no, it won't work any better than the path that you're using anyway. So if you've got a crummy Wi-Fi, sorry, go ahead.
Oh, I'm sorry. I keep forgetting we've got like a 2 or 3 second delay sometimes here. I was just saying that's absolutely true. I was agreeing with you.
Okay, good. I'm glad I wasn't wrong about that, but it scratched my head a few times over that. VPNs are useful, but they're not a cure for poor connectivity in the first place. That's what they're not intended to do. Okay, in fact, they'll probably make your connectivity a tiny bit worse anyway because of the extra, stuff that's going on. Hey, folks, you are watching or listening to This Week in Radio Tech, episode 291. I'm Kirk Harnack, along with Chris Tobin and our guest, Stephen Poole. Steve's the market chief engineer for Crawford Broadcasting in Birmingham, Alabama, and he's quite the IT expert. He's written a lot of great articles about how to get some cool stuff done, like local area storage and things like that. And he may want to give us a few pointers before we get to the end of our show. Our show this week is also brought to you in part by the folks at Omnia, and I want to tell you about the Omnia 11. We haven't talked about the Omnia 11 for a while, and I got to tell you, they keep making this box better and better and better. It is just amazing. First of all, it's a fantastic hardware platform with a super powerful CPU in it, and it's totally quiet, no fans, big heat sinks, a superior power supply. I mean, this power supply is, honest to goodness, it's expensive, and it's used by mobile carriers at their cell sites. That's the kind of ruggedness that the power supply itself has. It has a beautiful touchscreen on the front and a great remote control capability as well. Of course, all that's nice, but what really matters is the sound. And it's the sound of the Omnia 11 that is just absolutely amazing. Now, like any processor, you can adjust it well or adjust it poorly. I like a lot of the presets that are in the Omnia 11, and what I've noticed, and I got to tell you a tiny little story in support of this ad for the Omnia 11. A couple of years ago, my colleague Jim Armstrong and I were driving across, I think we were in northern Indiana. We were driving across northern Indiana, maybe it was northern Ohio, wherever we are. We were about 70 miles as the crow flies from an FM radio station that we knew had an Omnia 11 on the air. So we're driving along, and we're actually in a rented van, and the radio in it was okay, and we'd been driving together for about a day and a half and seeing some people, and we kind of knew what the radio sounded like. So we're getting used to how the radio sounds. So that's covered. So we punched this radio station that we knew had an Omnia 11. Okay, we're a rim shot. We're far away from it, and we weren't getting any closer. We were tangentially going by it. We're listening to it, and we thought, wow, this station sounds really good. And we were hearing detail and just delightful sound from some songs that we'd not really heard before. It sounded great. But what amazed us is when the morning team got on the air. The song ended, they went right into a little comedy bit. And I mean, the voices were so clear that I'm driving the van, and I look at Jim, and Jim looks at me, and both of our mouths are just open like, oh, that sounds amazing. I don't know. I don't remember what station it was, and I don't know who the engineer there is. But my goodness, this Omnia 11 was tuned up, tweaked up, and it sounded absolutely fantastic. The other Omnia 11 story is one night really late. I flew into Cleveland, Ohio, had a meeting there the next day at Telos, got a rental car, and I'm driving to the hotel, and I tune into a rock station in Cleveland, and I hear a Fleetwood Mac song at the end of a show. And I swear, I thought, is this a new mix? Have I never heard this mix before? The detail in this song was absolutely astounding and beautiful. I mean, I don't mean it was just busy. No. That wasn't it at all. I was just hearing lush instrumentation that I had not noticed before. And I think a lot of processors would squash that down. Now, probably if you listen to the CD directly and some great speakers in a quiet room, you'd hear that detail. Well, the Omnia 11 brought that detail out into the rental car that I was driving. Flabbergasted. I can't say enough good things about this box. They've really, worked on the algorithms, studied the way we hear and the way we enjoy voices, cymbals, trumpets. The researchers at Omnia have even listened to castanets buried in a song and seen, what can we do? What can we make sure that those things are clear? And it all comes out in the Omnia 11. Check it out if you would. You can contact your favorite dealer, see if you can get a demo if you need that. Go ahead and buy one. If for some crazy reason you don't like it, we can work it out to make you whole again and get the Omnia 11 back, but you won't want to let go of it. Just an amazing box. Omnia 11, thank you, Omnia, for sponsoring This Week in Radio Tech. It's our 291st show. Chris Tobin is along with us from New Jersey, and Stephen Poole from Birmingham, Alabama is here as well. So, Stephen, we've talked a bit about planning AoIP. We touched on IP addresses and networking and such as that. Thinking about what other considerations? I mean, you were presented with a Wheatnet system to put in. Any surprises? Anything that, hey, I got to read this manual? Or since you're a good networking guy, did it pretty much all go according to your expectations?
Let me tell you this, pleasant surprises. All very pleasant surprises. It was my first experience. This was 2006, early 2007. And I remember anyone out there who's listening and who's wondering if you should make the jump to it. I don't care if you've got a small facility with one control room and a production room. You will be astonished. First of all, I mean, only having to run 1 or 2 Cat5 cables is just amazing compared to, like, was it you or Chris talking about running the 25 pairs and the punch blocks? You know, that's the way we had to do it. Or even better yet, if you're on a budget, you can't afford the 25 pairs, so you just run 1,000,000 single strands of 8451.
Oh, that's the worst.
That too.
That's the worst.
But I mean, just the little conveniences like that. If you have a multi-station or multi-studio facility, this, I almost sound like a commercial now, but that's okay. You will not believe how handy it is to be able to hook a source up to any node in the network and then be able to pull it up anywhere else in the facility. I mean, that might not sound, but I mean, in the old days, for example, suppose for whatever reason, like here, we have a satellite dish out front of the building. It's almost 100 feet, 120 feet away from me. And so we put the receiver in the front of the building, but we needed to get the audio back into the engineering area, which is another 70 feet.
Yeah.
Just connect it to one of the cages in the control room, and it appears in engineering. It's absolutely beautiful. If you can share studios, it's more cost effective. You can build one really nice talk studio with a lot of really nice microphones in it, and then you can share that room between 2 different stations, between 2 different radio stations. So that's basically for me. And the reason I say it was a lot of pleasant surprises, maybe we're just crazy here in Alabama, but I would have somebody run into me or to my assistant Todd, would come running in like at 3 in the afternoon and say, oh, by the way, we've got a ball game coming on at 5:30 and we want to put it on 8:50 a.m. And we would literally be throwing wire across the floor and changing punches.
Oh, wow.
Well, you don't do that anymore with any kind of a decent audio routing network. You just don't do that. What do? You twirl a knob or push a couple of buttons until you bring that source up, and boom, you're covered. It's just you can't beat it. That's
Chris. Go ahead.
Pleasant surprises mostly. I mean, just how easy it was to get everything cooking.
I've always thought that switching from whether it's traditional point-to-point wiring or even a TDM router, which has plenty of advantages in and of itself, although it becomes limited in the number of cross points, and so a lot of radio stations would buy a TDM router, and then in a pretty short period of time they'd fill it up, and then they'd have to go back to patching around it or doing other things. And if they were often a single point of failure, where you can build an audio over IP system where it doesn't really have a single point of failure. You can get around a lot of different failures that way. Chris, did you come across these same serendipitous events with your experience?
Oh, absolutely. Absolutely. One of the things we had to build into the system, and I remember this very well, I working with the cluster of stations I was with here in New York, some of the engineers in the group were somewhat skeptical of IP in general because of their experiences with the office computer networking issues. And so I on several occasions would walk them through my project plan, and they'd be like, well, you're talking about Ethernet switches, and you're talking, what happens if a switch fails and you lose half the network? I was like, well, let's take the old way of thinking and we build redundancy into the IP in a fashion that people at Cisco wouldn't even understand. And they looked at me like, what? I said, well, we've got about 5 Cisco switches. I'm told that we're going to do a high-speed bus backplane interconnect, so they look like virtually one IP address, but they have several internally. And they said, yeah, well, that's the way you're supposed to do it. I said, you're right. We're not. And they said, well, why not? I said, here's what happens. Let me see if this switch fails. What happens to the rest of the cluster? Because the master just failed, and the other 4 were slave to it. Oh, yeah, that's right. You'll have an issue because now they have to relearn. Yeah, we can't have that. I've got 4 studios that need to be able to go to air at any time. There's always one on the air, and then we switch between them for the newscasts. Oh, so what I did was each switch had its own IP address. Each studio was attached to that switch. And then we had the front panel G-bit connections to bring the high speed back and forth. So I could actually unplug one switch, which I did do during a demonstration, and watch it fail over to the other active switch, which had its own IP that everybody was looking at as the fault, redundant. And everyone was like, did you just kill the switch in the middle of the day? And I said, yeah, that's the point behind redundancy and fault tolerance. And that was one of the wonderful things I loved about the IP approach. Because if that was a TDM frame and we lost one of the PSUs, guess what? My 32 by 32, 64 by 64 switch frame I just may have lost all my cross points. So to move along with the ease of use of IP, as Steve pointed out, with the radio station game coming up, we had elections, political presidential elections coming up. We had to cover that, and we were an ABC news affiliate, so we had the opportunity to operate our coverage from the ABC newsroom in Manhattan and do our local stuff and be part of our network feeds right from their facility. So we could be right there at the action, get all the all the polling info, the whole bit you want to have for the image of the audience to be able to say we're at ABC headquarters. However, had this been the old-fashioned way of doing things or the more traditional approach, we would only have been able to connect a talking mic, headphone, and ISDN back from a booth to our newsroom because why? We had no other way of controlling what we had at our main newsroom. But with the IP approach, picture this. 2 news anchors in a off-site studio with the ability to VPN into the newsroom computer system, call up their scripts and their audio, and they play it all out right from that facility, as if they're in the newsroom, which was, in this case, 25 blocks away.
Oh, wow.
And, oh, yeah, but now we also have several remote or outside broadcast feeds coming in from the various polling headquarters that we had to take care of. How many times have you had issues with audio levels and you go, wow, what do we do now? With the IP, and I'll use this Livewire as the example, I could remote into my Livewire node that had that particular remote feed, whether it was coming in on a ISDN or T1 or whatever connectivity we had, and I can adjust the levels and watch it. I did this purposely to demonstrate to the programming folks that were sitting with me offsite, and they're looking at me going, did you just fix the polling headquarter feed that we just had distortion from here? I said, yeah. What? I said, we're good. We're good for the night. Everything's... Oh, by the way, did I mention that we also had mix-minus switching that we had to do, and we did it from the remote location. I had a nice screen on a laptop, and it was the iProfiler, Pathfinder, and there were little buttons I created in green and red, depending which was what. And the producers looked at me going, so if I need to give mix-minus to so-and-so, but then release it and give it to somebody else because we're going to them after the round robin, what do? I said, just click here, click here, click here. Just follow the names, and just when you do it, it'll tick-tock back and forth. And again, program director stood there, looked at me, he goes, are we switching mix-minuses from off-site? I said, yes. You don't have to use that big button panel at the editor's desk? I said, no. Matter of fact, the editor is now focused on doing more editorial material while we do the heavy lifting. So for those of you who are still trying to get your head around the fact that IP is something of not a fad, and, it's all about your imagination, and just think about it. You have a telco closet that's down the hall. Take a node, whether it be a Wheatnet or a Livewire, drop the node in that room, one cable back to your frame, or 2 for redundancy if you'd like, back to your frame, and now all of a sudden your telco type stuff or satellite audio or satellite material is now available on your network. In the old days, there was that multi-pair cable run you had to do and hope that you had the right connections, or then there was that loss of audio because you didn't punch it right and the high frequencies were lost. Well, what the heck happened here? Well, the phone company tells you, well, you can't do anything about it. These are things you have to think about, and it makes total sense. And then you got that general manager who wants to be able to hear the stations in the cluster because he's just a fan of radio. Well, that's what he says. And Oh yeah, but wait a minute. His office is all the way on the other side of the building. Oh, we got pop ceiling tiles. Oh, it's gonna be a mess. No.
Yep.
You got Cat 5. Now you go to your building IT group or your corporate IT group and say, look, guys, I need a cable run from here to there. I'll take care of what goes in and out of it. You just give me the infrastructure. Sort of like calling the phone company for a phone line. I got the instrument. I just need the connection from the point A to point B. That's what I used to do. I'd call up the IT guys and say, can you guys install a cable? Sure. Okay, thanks. And I'd show up with a node, a box, plug it in. They go, what's that? I said, don't worry about it. And there was a little routing switcher panel. Now the GM has audio from anywhere in the plant. Well, of course, we give them conditional access. We don't.
Yeah, conditional. Yeah, exactly.
But these are things you could do, yes, with a mechanical panel or maybe the other types of routing switches that are out there. But remember what you had to do to pull the cable for the control head for a routing switcher. Now I worked in a TV and radio facility, so we did some TV routing, video routing, and you try doing that with the video router and pulling the cable. It's no fun. But you can do a lot. It's a lot of fun. You just have to be open-minded. But the trick is, and Steve was right, in the beginning, the foundation, lay the foundation, write it out or type it out, whatever you want. Make sure everything has its place in the system. IP addresses, your switches. If you do buy switches, make sure they are managed the proper type. I know when I was doing it, and Steve sounds like he was doing it about the same time I was back in 2006, 2007. This was early on, so you only had, I think, maybe 2-3 choices for really well-managed switches you could use. The Cisco 2900 series, I think it was, or 3900, something like that.
Yes.
And I think HP Pro Curve was the other ones that were real popular. Nowadays, almost anything can handle it. But make sure you understand why you're doing managed switch. Make sure you understand why you're doing static IPs, or at least properly IP addressing, and also security. Right now, nowadays, I would say security is definitely top of the list. Back then, it was sort of there, but we were still wild, wild west. Today, it's more matured.
I've got a tip coming up, but I want to hear from Stephen first before I pass this tip along. Stephen, in your audio over IP system, what did you find that was serendipitous? Like, oh my gosh, I can do this now. What surprised you?
How easy it is to set up a mix minus. That was one of them.
Yeah.
I don't know. It's like Christmas. It's like the candy store. Well, one thing you can do, you can pull up the microphones from a different control room and listen to that guy when he's not on air,
Well, yes, you can do that.
You can hear what he's saying, and then you go in and say, so, she likes your new hairdo, huh?
That's the NSA option.
NSA option. So Stephen, listen to my tip and see if it's similar for Wheatnet. In an Axia system, one of the things that you do want to take care about, and if you're looking at getting a new audio over IP system, and if you're new to it, no matter what brand it is, let me strongly suggest that you have a conversation with the support people at the company and say, I'm new to this. What's important that I do? And the people at Axia, at the support group there, they will tell you, okay, first of all, whatever switch is going to be your core switch, the main thing, that needs to have the lowest IP address on the system. At least with the Cisco switches that we use, that tends to be how core networking is facilitated. As far as I believe that's where the querier really takes place. So the core switch, at least in an Axis system, needs to have the lowest IP. It doesn't have to be 1 or 0 or 2. It could be 10, as long as 10, .10 is the lowest IP address on the system. For myself, so I'll make, because I'm always worried about needing something else, I'll make my core switch, .5, and that way I can go down farther if I need to. What was my core switch will now be an edge switch, and now I'm putting a new, bigger core switch in. So I'll have another number I can go down to for it. I always like to think ahead. And then I tend to divide studios or racks into groups of 10 by IP address. So this studio will be 10.216.0.50, and that studio will start. The next studio will start with .60, and the next studio will start with .70. And I might make every mixing engine the dots the .70, and the console that's running it .71, and then the first node that's in there .72 or 73, whatever it may be. So I'll tend to keep 10 devices per studio. You're rarely going to have more than 10 devices in a given studio. So I go by tens, and you got room for 25, 24 studios at that point. Very few people have that. It is possible with proper planning to go really big, and I'll give an example. Radio Free Europe and Radio Liberty are in a huge facility in Prague, Czech Republic. They have a Livewire network, and it has over 4,000 sources coming into it, and about 2,000 destinations in it. So there's a lot of IP addresses going on there. Yeah. So anyway, that's my tip. Talk to the support guy. See, okay, now what is critical in terms of addressing that I do have to plan out? One other thing that I'd like to say is a lot of folks maybe overthink this. They think, okay, if I have an analog node, or in the Wheatnet version, a blade, and it's an analog one, then I'm going to give it an IP address with the last octet will have a 1 as the middle digit, and if it's a AES node, it'll have a 2 as the middle digit, and it's really complicated. So probably Wheatnet's the same way, but in the Axia world, when you plug a source into an input device like a node, or if it's a source that is natively AoIP, you can give it a name on the network. Typically, you'll be able to give it a fully descriptive name. Like Mic 1 at, then maybe an at symbol is part of the nomenclature, Studio 5. Well, no matter where you are on the network, this isn't the Mic 1 in Studio 4, or this Mic 1 or that Mic 1. It's the Mic 1 in Studio 5. Now, when you assign it to an audio console, probably the audio console in Studio 5, you don't need to call it at Studio 5. You're in Studio 5. You don't have to call it that. You can just call it Mic 1, and that's fine, and that's what will show up on the audio console. You can usually, specify the friendly name on the console separately. So my point is you can, everything you need to know is probably there, but it's good to know what the manufacturer designed in so that you kind of know how to follow their idea, their built-in rules, if you will, so that you can get back the most use out of it without overcomplicating it. Hope I said that well enough. Steve, does that agree with your experience?
Yes.
That's a good answer. That's a good answer.
Absolutely.
No, I agree. We use a different method here. But it's still the same principle. We use studio number and then source type. Like our studios are G1 through G5, or the talk studios are S1 through S5, and then it'll be like S1 Mic 1, S1 Mic 2. We do it like that, but it's the same principle.
Yeah.
Well, let me, from all this talk, I would like to share now, Chris and you and Chris can probably disagree with me. What I'm discovering now, though, is that if you're setting up, because let's face it, once you start doing audio over IP, you're going to love it. We're trying to think now of ways to actually send it over our, we use the microwave data links as STLs now, like a lot of people are doing. I mean, we're actually thinking of ways to make, everything in Alabama just part of the AoIP network. Mm-hmm. And each year when budget time comes along, we buy a few more goodies. But I will tell you this. Most people know that it's a bad idea to daisy chain network switches. Mm-hmm. I mean, we all have done that, especially in the early days when we didn't know any better. It's not like I have an 8-port switch in engineering, but then when I get to the front of the building, I need a whole bunch of more plugs. So I stick another 8-port up there and split it. And then that goes 50 feet this way. I need some more holes. So I stick in another switch and start splitting it. Well, of course, that is just not going to work if you've got a lot of traffic going along. Now, the two ways you can do it is use, my suggestion and my personal recommendation is buy the largest switch and the fastest switch and the bestest switch that you can afford. Mm-hmm. We've got a 50-port now just on our automation network, and we run home runs to every machine, from engineering to that machine. We do not use multiple switches, and we've had far, far less trouble since doing that. If you do have to stack switches, do the way Chris talks about doing it, is like you take each switch and then hook them together with that gigabit. You know, hook them together with a gigabit link, and if it's a smart switch, be sure to go in there, read the manual. It will tell you how to set that up and what the nomenclature is, but look for a way to, like, say, trunk or link or whatever their term is.
Yeah.
To make sure that they are linked that way, high speed without any barriers.
You know, I didn't realize this is such a great conversation. We could talk for hours, and we're actually getting pretty close to the end of our show time. I've got a quick note, and then we're going to jump into a commercial, and then we'll come back. And Steve and Chris, maybe if you could each have your favorite tip about AoIP networking. Maybe you've already given it. Maybe you can think of another tip. You know, what would you like to leave our listeners and viewers with? I want to mention that I mentioned earlier this Radio Free Europe, Radio Liberty, and they had an interesting requirement. They wanted to have dual core switches, and they had some big honking Cisco 6500 series switches, but they wanted them on 2 switches on 2 different floors. I mean, if the 5th floor burned up, they wanted the 4th floor to keep on working. And so what we found out was that we could take their edge switches, and that's most everything was core to edge, and no further than that. That's you wouldn't daisy chain any more switches, but core switches, edge switches. And they found out that using a Cisco technique, they could run a trunk from each edge switch, 2 trunks, one to each of the 2 core switches, core A and core B. And then they did something interesting. So, and each edge switch would be receiving data from each of the core switches, the same data in parallel from core A and core B. But we found that was a little bit problematic, and we had to figure out how do we tell the edge switches to discard this redundant data and not get confused about it. Well, in core switch B, we added an extra hop metric. In other words, we made it look like it had gone through one more hop when it was going through core switch B than core switch A. And so when this data was received, it was still coming in at the same time. The timing was still the same. If an edge switch was receiving audio over IP data from core A, it would have this metric for the number of hops it had taken, and core B would have that metric plus 1. Well, the metric plus 1 was obviously older, took longer to get there, had more hops. So the edge switch knew to discard all that, and that's fine. And as soon as the if core switch A ever had to go offline, well, then all of a sudden core switch B has the least number of hops because it's also the only one there. So the edge switches would just keep on plugging and would not miss a beat. Tested it over and over, and it worked great. And it was an amazing way to actually have complete redundancy on the core switches. And now if they lost an edge switch, a studio or 2 would go down. They typically use an edge switch to feed 2 studios, but they had like 50 studios. So they get by with that. All right, that was my little tip. We're gonna hear from Lavo, and then we'll be back with Steve and Chris for a final word. Lavo is a manufacturer of audio consoles in Germany, and I know you've heard of them. I mean, LAWO, they make some fantastically beautiful consoles, and they've taken their engineering prowess and put it into a smaller console. And this one's really interesting because it's a virtual radio mixing console. You actually run it with a touch screen. You put your fingers like this. You put your fingers on it like this, and you run the faders up and down like that. And you push buttons with your fingers. It's amazing, and it's because it's laid out. It's not a picture of a traditional console as the app. It's designed for your fingers to run up and down on a big, beautiful touchscreen, and it's multi-touch. So you can turn something on and off, run a couple of faders up and down at the same time. Here it is. Here's the website. This is a great picture of a tight shot of this virtual console. It's called the Crystal Clear virtual radio mixing console. And in the upper right on that screen there, you'll see Mike Dosh. He's got his hand forward there. He is demonstrating this Crystal Clear console. If this technology is interesting to you, by the way, it is an audio over IP console as well. If this is interesting to you, go to that website, lawo.com, look for radio products, and look for Crystal Clear, and click on that video of Mike Dosh, and he will explain to you not only the operational features and benefits of this console. They thought of some interesting things, but he'll also give you the story about the virtual part of it, how you can have your station running, and you know what? I'm going to do my show from my office today. And you can unplug it and take the the PC, which gives you this virtual console, and go plug it in somewhere else on the on the same network, and be right there with it. Hey, you could even run a microphone from your office back to the crystal portion of the whole thing and be on the air that way. It's just amazing what this thing can do. Now, the heart of this console is the one rack unit box that has the smarts in it. This has audio inputs and outputs, including mic preamps, headphone outputs, line level inputs and outputs, and AES digital ins and outs. Plus, it's got that Ethernet jack for the Ravenna network, which also supports AES 67. Plus, it has available dual redundant power supplies, and there's some GPIO on there to light up your tally light, or to push a start button and have a CD player take off and start just like that. You could probably put a relay in, remote start your Victrola if you want to. It is just amazing what you can do with this AoIP console. The crystal clear from Lavo, all the features you want in a really interesting touchscreen design. Check it out at LAWO.com. We sure thank them for sponsoring this part of This Week in Radio Tech. All right, Chris Tobin, you always have a good tip for us. Take it away.
Okay, well, since we're talking AoIP, Ethernet cables, all that sort of stuff, my trusty little tool here, this is out of production, but you can still get them, I believe, used, is a Fluke One Touch Series 2 Pro Network Assistant. Basically what it does is it lets you, you can do, cable wire mapping, you can check distances, you can check if your switch is active, if you're on a port that plugged into a jack and there's actually a switch at the other end, you can measure the length of the cable, you can tell if it's crossover or not, or if it's shorted, or if there's open pins. So it's a handy little guy. The newer versions now have, I think, fiber and Wi-Fi built in, so they're a little more costly. But you get these guys for a couple $100 on the internet. So it's worth looking into. And it's very handy. Trust me, I've made a dozen cables this week, and just using this little bugger, I got through it with no problem. Didn't have to worry about a thing. Now, speaking of making cables, so we're talking Ethernet. Don't forget, we talked about this once before. Get your little cable making kit here. Let's show this to the camera. For those of you who are listening only, you'll have to imagine a cable device, little crimping tool. And with this box, don't forget, we talked about this last time. What is this little piece of paper show? Let me see if I can do this without the light getting in the way.
Color.
It's the color code for RJ45. Because we all keep that to our memory. We keep that committed to memory. And then there's also that opportunity. Let's not forget, sometimes you need to talk directly to the device. Crossover cable, pin out. Now, you keep these handy because it's not the kind of thing you should be always trying to remember. So that's my tip. Just try and organize yourself so that not only have you organized your IP addresses in a proper manner, your naming conventions are making sense with all the multiple studios, but at least your infrastructure will be sound. Because I can tell you, I did a project 3 years ago, and we did 200 cable runs of Cat5, and for some reason, they wouldn't let us terminate the cables. They had some other company do it. Fine, whatever. Guess what? After the project was ended and it was all trying to come back in for the broadcast portion, we had a lot of issues. And it turned out that the crimps weren't proper. Some of the wires weren't where they should be. So also remember, with Cat5, you're dealing with RF signals. So make sure when you make those connectors, you make sure the twist is as close as you can to the connector. There are documents you can download to tell you exactly how to keep and maintain it. Cat5, Cat5e is easy to do. Once you get into Cat6 and the other stuff, it gets a little more complicated. But Belden has done a nice job of creating connectors that help you to keep the twist where they should be, so you have near and far end issues are not anymore a problem. So that's my tip. Just get your infrastructure in place.
I'll add to that tip. There are YouTube videos that show you how to do this stuff. If you're going to happen to run, for example, shielded cable, there's YouTube videos showing you how to do shielded cable. And one of the things that people make the mistake of thinking, they'll buy Cat6 cable, but then they'll buy Cat5 connectors, which is fine. They'll work, but it's no longer necessarily going to be a Cat6 quality connection. A Cat6 connector is a different connector internally. It's got little guides. And
you won't be able to certify it.
Yeah. You won't be able to certify. And that, Cat5e will carry a lot of stuff. I've never had a problem with Cat5e carrying gigabit, but just be aware that is a difference. Yeah.
Oh, one other tip I have to remind people, and I was talking to someone today about it. If you're running fiber optic cable between your switches or maybe your consoles, or depending on the setup you have, try not to put the fiber optic cable in cable trays that have vibration, or at least do the proper fiber jackets. Don't just do the orange little guy and just toss it in the cable tray and go. I worked at a facility where we were having issues with the consoles losing connectivity with the main switches, and we couldn't figure out why until one day, talking to a fiber expert. He came in a TDR, an OTDR, right? Yeah, optic time delay reflectometer, and we were looking at the wave, and we were noticing these little bumps, just every so often, just a little bump. I'm like, what the heck is that from? The guy's like, okay, this is a point-to-point connection. Why do we have bumps in the light wave? Turns out that the mechanical stress being applied by the air conditioning ducts to the cable tray were bumping the cables. It was actually physically shaking the fiber because it wasn't in a Porflex pathway. It was just literally little orange, the orange fiber jackets tossed in a cable tray.
Oh,
so we went up there, and sure enough, I took it. I started shaking it really, really vibrant, and you could see the OTDR was just all over the place. Like, well, I'll be darned. So it was something as simple as that. I just want to remind, because I mentioned to somebody a while back, a cellular. I was at a cellular site with a friend of mine who works for a cellular company. I can't name where, and his job is to certify the sites, and they're doing a lot of fiber. I told him this story. He goes, "Oh yeah." Oh yeah, he goes, you kidding me? We have a standard. We have to meet to run a fiber between one point to the other. You look at the jacket, the armor, the housing. You could take a sledgehammer to it. You'll never even get to the fiber. And he goes, for that reason alone. So just think about infrastructure. Understand the infrastructure.
There's lots of information out there. I love YouTube. Not everybody on YouTube knows what they're talking about, so you may want to look at a few videos, but I love watching videos to find out how to do something. Steve, how about you? What tip can you leave us with?
Well, first tip I'm going to give you is that apparently Tobin is a dinosaur. You can get all those guides and printouts and all that. You can get them on your smartphone now.
Yes, you can. And then I have friends of mine who have managed to break them or not get the right information and the battery dies. Yes. I'm a friendly dinosaur, not a T-Rex, but I'm a friendly dinosaur.
I've had a lot. I have a network analyzer, and I've tried to do a web search here while I was listening to Chris, trying to remember the brand. It's in my office. I don't want to run go get it. It's not a fluke, though. It was pretty rational price. I bought it new for like $450, but it'll do the distance to break. It'll do the speed test. It'll do the crosstalk tests and everything. But I agree with him. Either pick up a good used fluke or find something. For the connectors, there are some. You guys may be aware of this. You're going to have to spend about $50 to $60 on the crimp and cut tool, but there are RJ45 connectors now for Cat 6 that actually have little holes in the end, and you slip and you stick it in and clip. Oh, you use those? That's the only one you got.
No, I've seen them, but I haven't used them. So good to hear about them. Yeah.
Yeah, because when you get done with that, you can make sure that your twists are all the way up in that thing as far as you can get it, and then you put them on that analyzer, and that analyzer's going to love those cables. It's going to say, yeah, we can run lots of stuff through this. It's loud.
You know what we'd be the biggest billionaires if we could come up with the following device. The box itself, some little half the size of a shoebox, and you take the end of a piece of Cat 5e or Cat 6 cable, and it's just a cut end. It's nothing prepared about it. And you take this cable and you stick it into a hole like a pencil sharpener in the top of the box, and it goes and it does that for a few seconds. You pull it out, and it has a fully booted Cat 6 connector on it.
Wait, what was that noise again? Okay, just wanted to make sure.
Maybe version 2 would make nicer noises like and you pull it out. It's a fully booted Cat 6 connector that's already tested and everything's wonderful. Wouldn't that be great?
It would be good. Actually, I think they have things like that at the big manufacturers, but we couldn't afford them.
Yeah,
they may have something like that. Or them, for all I know, the Chinese pay their people 50 cents a week. Okay, you just untwist wires.
Well, guys, we have used up our allocation of bits for this show, speaking of bits. Yep. I want to thank Stephen Poole for becoming available to join us this afternoon. Steve, it's been great to chat with you. Thanks for joining us and educating us on your AoIP system there.
I had a ball. Thank you.
And Chris Tobin, thank you very much. Staying late at work, and appreciate you bringing knowledge and wisdom to every show. I really do.
just trying to keep it practical. That's all.
Yeah. Well, you do. Absolutely. And then there's me just trying to hold the whole thing together. And thank goodness I have people like Suncast and Chris Tobin and others to help out and make it all work. Suncast, thank you very much for producing This Week in Radio Tech. You always make us look much better than we actually are. Stay tuned. Next week, we'll have another exciting episode, number 292, coming up of This Week in Radio Tech. And thanks to our sponsors as well, and to Andrew Zarian and the GFQ Network. Check it out for other fine podcasts of quite varying interests. You're going to like a lot of the stuff you see on it. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.